Morning students, today we are going to see about I/O and memory interfacing. So, before seeing what is memory and I/O interfacing, let us see what is interface. Interface is a path of communication between two components, that is between the memory interface and I/O. So, the interfacing is two types. That is, one is your I/O interfacing, and second one is your memory interfacing. So, what is memory interfacing? When we are executing any instruction, we need the microprocessor to access the memory for reading instructions, codes, and data stored in the memory. For this, both the memory and the microprocessor require some signal to read from and to write to the register. The interfacing process includes some key factors to match with the memory requirements and also the microprocessor signal. The interfacing circuit therefore should be designed in such a way that it matches the memory signal requirements with signal and the microprocessor. So this is it to be your memory interfacing, and next is your I/O interfacing. So there are various communication devices such as keyboard, mouse, printer. So we need an interface the keyboard and other devices with a microprocessor by using latches and buffer. So this type of interfacing is said to be your I/O interfacing. Let us see what is synchronous and asynchronous data transfer. So usually synchronous data transfer occur when the peripheral is located within the same computer as the CPU, and close approximately allows all the state bits change at the same time on a common clock. And whereas the asynchronous data transfer do not require the source and destination user same system clock. Okay, that is said to be your asynchronous output. So hope you all clear about what is memory and I/O interfacing and synchronous and asynchronous data transfer. Next, let us see the basic block diagram of memory and I/O interfacing. So there are various communication devices like keyboard, mouse, printer, ROM, RAM. So we need to interface the keyboard and other devices with the microprocessor by using a latch and buffer. Okay, so this type of interface is known as I/O interfacing. So in this diagram, he has a basic communications such as address bus, data bus, control bus, and whereas these are connected to the microprocessor and the memory and I/O devices. So in 8085, the A15 to A8 are the pins of higher address bus, and AD7 to AD0 is a pin configuration for lower address bus and data bus, and AL is your arithmetic logic unit. Okay, and read operation, write operation, and ready. These are the way of communications. Okay, so in I/O interfacing, RAM, ROM, and EEPROM or I/O devices to the 8086 microprocessor. So several memory chips or I/O devices can be connected to the microprocessor, and address decoding circuit is used to select the required I/O devices or memory chip. Okay. Next, let us see the basic similarities and difference between memory mapped I/O and I/O mapped I/O. So in your memory mapped I/O is treated as a memory, and whereas in your I/O mapped I/O is treated as input output. Okay, so in your memory mapped I/O, it is a 16-bit addressing, whereas in your I/O mapped I/O, it is an 8-bit addressing. And whereas in memory mapped I/O, it is a more decoded hardware, and whereas in I/O mapped, it is a less decoded hardware, and it can address up to 64 kilo location for memory mapped I/O, and whereas in I/O map you can represent 256 locations, and compared to I/O, the memory map has less memory, and whereas in I/O the whole memory access address spaces is available. Okay, next is your in your memory map the memory instructions are used, whereas in your I/O map the instructions are used like input and output. Okay, and whereas your memory map the control signals are used, whereas in your I/O map special control signals are used. Whereas in your memory map all arithmetic and logical operations can be performed on data, Whereas in your IO map, all arithmetic and logical operation cannot be performed by data. So, whereas in your memory map, the data transfer between register and register and input and output. Here, the data transfer between accumulator and input and output. So, and there are two ways of communications in which the microprocessor cannot connect with the outside world. One is your serial communication interface, and another one is your parallel communication interface. So in your serial communication interface, the interface gets a single byte of data from a microprocessor and send it bit by bit to the other system serially, and similarly vice versa. Whereas in your parallel communication interface, that is, in this type of communication, the interface gets a byte of data from microprocessor and sent it bit by bit to the other system in parallel fashion, which is similar to synchronous and asynchronous data. And in this topic, we have discussed about what is I/O and memory interfacing, and what is synchronous and asynchronous data transfer, and what are the common buses used, that is address bus, data bus and control bus has been used, and what are the pin connections that are required for IT85 interfacing pins with memory and I/O devices, and what are the two ways of communication, that is serial and parallel interface, serial and parallel communication interface. Okay, I hope you all clear with this topic. If you have any clarification, let me know. Thank you.